Hello! In this video, we are going to prove the following theorem. Let x be a real number greater than 0. Then the sequence 1 plus x over n to the power of n is strictly increasing. Now, to prove that this sequence is strictly increasing, we're trying to prove for all positive integers n, the n plus 1th term of this sequence is strictly greater than the nth term of this sequence. So let's first give ourselves an arbitrary positive integer n. And now let's write out the n plus 1th term of this sequence. So this would be the n plus 1th term. So let's first rewrite 1 as n plus 1 over n plus 1. Well then, we can combine these two fractions into a single fraction. And let's actually swap the n and the 1. So we have this. But now, I'm actually going to take n plus x, and we're going to divide and multiply it by n. Now, what we are really doing here is we are adding n plus x over n by itself n times. Right? So notice, we have a list of n plus 1 positive numbers, and we're taking the sum and dividing it by n plus 1. So let's apply the AM-GM inequality. If we recall, the AM-GM inequality says the following. Suppose A1, A2, AM is a list of positive real numbers. Then the arithmetic mean of the list is greater than or equal to the geometric mean of the list. Now, it turns out that this inequality is strict if the numbers in this list are not all equal. So we have this. But then, it follows if we raise both sides of this inequality to the power of n, then the sign of the inequality still holds. So now, let's apply the AM-GM inequality to the list of positive numbers that we have in our proof. Now, we're going to take n to be n plus 1. So the list of positive real numbers that we're considering is this list. And this list of positive numbers are not all equal to each other. Because, for example, if we consider 1 and n plus x over n, well, since x is greater than 0, that implies n plus x is greater than n. But then if we divide n on both sides, we get n plus x over n is greater than 1. So these two guys are not equal. So this is a list of positive real numbers which are not all equal. Therefore, the strict AM-GM inequality must be true. So this guy must be greater than the product of all of these guys. But notice, since we have n of these, we're really multiplying this guy by itself n times. So really, this is just n plus x over n to the power of n. But then, this is just 1 plus x over n to the power of n. So we have shown that the n plus 1th term of the sequence is strictly greater than the nth term of the sequence. And since n was arbitrary, this proves that the sequence is strictly increasing. And so this completes the proof. And so yeah, that's pretty much it for this video.